Hello, everyone. Welcome to the webinar today, brought to you by the ASQ Statistics Division. Our topic today is Essential Lingo for Transformation to Quality 4.0, and this is a continuing series from our data science interest group. Our speaker today is Afaq Ahmed, who is a principal consultant and trainer at Torque in Irvine, California. His core skills consist of operational excellence design and implementation, management systems implementation, business performance improvement, assessment, and supply chain improvement. He has worked in a wide variety of industries, such as oil and gas, aerospace, automotive, and others in the US, and for Saudi Aramco as strategic transformation professional. He has presented in many international conferences and is an author of several articles. He has a master's degree in mechanical engineering from the University of Southern California, and he is a senior member of ASQ. He's also an ASQ-certified manager of quality organizational excellence, quality engineer and quality auditor, and an Exemplar Global certified quality management system lead assessor. And so with that, we are going to start the webinar. If you have questions during the webinar, I would ask that you type them into the chat. And then at the end of the presentation, we will have them answered. And after the webinar, we will post the recording to our YouTube channel, and I will be sending you an email that has links to where you can get the slides, where you can find the YouTube channel, and it will also have your continuing education credits. So you can expect to have that from me within a week or so. And with that, we will start the presentation.
Hello everyone, my name is Afaq Ahmed and Fayzee.
Excuse me while I have technical issues here for a second. I'm going to do everything in the right order here.
Hello everyone, my name is Afaq Ahmed and Fayzee. I'm the principal consultant and trainer for my core skill sets consist of operational excellence implementation, business performance improvement, business processes assessments, and supply chain improvements. Wide variety of industries, aerospace, automotive, device, and others, and for Saudi Aramco is a strategic transformation profession. I completed a master's degree in mechanical engineering from the University of Southern California. I'm a senior member of American Society for Quality and ASQ-certified manager of quality and organizational excellence, quality engineer, and quality auditor, and an Exemplar Global certified quality management system lead assessor. The outline of this presentation consists of a brief review of my previous presentation, followed by continuation of introduction to Industry 4.0 technologies.
Okay, I'm going to stop it for a minute. It is a recorded presentation, and so I am going to see if I can fix the audio so that it's louder for everyone. So give me a second.
Hello everyone, my name is Afaq Ahmed. Outline of this presentation consists of a brief review of my previous presentation, followed by continuation of introduction to Industry 4.0 technologies. I'll keep this presentation to around 20 minutes, followed by 10 minutes of questions and answers. In my previous presentation, I provided the definition of Industry 4.0, touched upon its emerging technologies, and talked about leveraging these technologies for quality to transform to Quality 4.0. These presentations are available on YouTube, and link is provided on this slide. Industry 4.0 revolution is an integration of information and communication technologies with machines and humans. What are these?
Sorry, I practiced this and apparently it is not working as well as I thought. I'm gonna just go old school here and disconnect my other screen and see if that works. All right. Well, let's see which time is the charm here for getting the right sound and everything. Darn. Let me work on my sound for a second and then I will share my screen again. Okay, I changed the sound, so let's see if this works.
outline of this presentation consists of a brief review of my previous presentation, followed by continuation of introduction to Industry 4.0 technologies. I'll keep this presentation to around 20 minutes, followed by 10 minutes of questions and answers. In my previous presentation, I provided the definition of Industry 4.0, touched upon its emerging technologies, and talked about leveraging these technologies for quality to transform to Quality 4.0. These presentations are available on YouTube, and link is provided on this slide. Industry 4.0 revolution is an integration of information and communication technologies with machines and humans. What are these advanced technologies? It includes Internet of Things, IoT, and Industrial Internet of Things, IIoT, Big Data, Cloud Analytics, Artificial Intelligence, Machine Learning, Cyber Physical Systems, and others. Let's get started where we ended the last presentation of this series, that is machine learning. In the following slides, I will share with you definition of machine learning, types of machine learning, techniques, algorithms, libraries, data processing tools, and machine learning platforms. Machine learning is a branch of artificial intelligence. It is also known as automated learning. Machine learning is a technique where computers acquire knowledge and use that knowledge to make predictions. How do they do that? Using algorithms. Algorithms are computer programs that have the capability to acquire knowledge through learning and apply that knowledge to analyze data and predict outcomes. These predictions are useful in extracting value-added information from the data to make informed business decisions. Algorithms learn from examples in the same way that children learn languages or patterns. Now, you may be saying that computer programs are not something novel. They have been there for ages. So what's the big deal about machine learning? The most significant advantage of machine learning is that traditional programming produces rigid codes which do not adapt to changes in data sets input. The machine learning model can learn from data sets and make predictions from acquired knowledge. The resulting output is used to improve future predictions using the new data sets without modifying the program. Thus, the machine learning model is adaptable to changes in data, unlike a traditional computer program. Machine learning is applied in manufacturing, healthcare, financial services, and many other fields. There are different types of machine learning techniques depending on how computers learn and draw inferences. Before we take a deep dive into machine learning, let's look at some terms that will help in understanding machine learning. Binary data. It is a type of categorical data. It has exactly two values. For example, test, pass, or test, fail. Continuous data. Measured data expressed numerically is called continuous data. For example, K2 is at 8,611 meters above sea level. This van gives 20 miles per gallon and customer wait time is 3 minutes. Categorical data. Data that is classified into different categories is called categorical data. A spreadsheet of inventory of black, white, gray, and red automobiles is a good example of categorical data. Classification. It is the operation of separating various entities into several classes. For example, you can see that row 1 consists of objects related to transportation, while row 2 consists of things related to traffic. Binary classification. It predicts the answer to a yes or no question. For example, is this email spam or not spam? Is this a tree or a person? Is this an apple or an orange? Multi-class classification. It predicts the multiple categories from a list. For example, what is the category of this news? Business, sports, or weather? What is the genre of this song? Rock, blues, country, or jazz? What is the category of this defect? Wet color, tear, or blemish? Clustering. The grouping of the data based on similarities and dissimilarities. For example, groupings of cats and dogs from a collection of images. Linear regression analysis. It is used to predict the value of a continuous dependent variable from independent variable data. Logistic regression analysis. It makes prediction on categorical dependent variables with the knowledge of independent variables. Predictions are binary in nature. Target. It is the thing that we are trying to predict using the model. It is also called response, dependent variable, or labels. This slide shows some examples of machine learning use cases, that is, detect quality issues in mass printing, for example, color bleeding, color variation, and a tear. Predictive machine maintenance, for example, forecasting future maintenance requirements in near real time. Spam emails filtering, for example, the email is spam or not spam. The field of machine learning is often classified into 3 broad categories: supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, examples of inputs and outputs, also known as labels, are provided to the algorithm. The resulting model learns to predict the output from these examples. Let me explain how supervised learning works with an example of spam emails filtering. In supervised learning, to train the model, the machine learning algorithm is provided with emails that are labeled as spam or not spam. For example, emails such as winning a lottery, a surprise gift, or inheriting large sums of money are labeled as spam, and emails such as stock market news, weather report, sports news is labeled as not spam. The model figures out a rule from this training data to predict whether the email is spam or not spam. Once the training is complete and results are validated, the machine learning models applies the rule to newly arrived emails and classifies the emails as spam or not spam. The spam emails are then sent to the junk folder and spam emails are sent to the inbox. For continuous type data, supervised learning can be used for predicting an output value of a dependent variable. For example, using this technique, customer wait time, complaint processing time, etc., could be predicted. The slide shows different types of variables, instrument used for measurement, and units. The regression techniques works on linear regression. For categorical data, supervised learning can be used for classifying data into different classes. For example, the data could be categorical label data of quality defects from a high-speed printing press. The classification technique works on logistic regression. In machine learning, we usually refer to linear regression as regression and logistic regression as classification. Both techniques can be used in training the supervised training model. As explained earlier, supervised learning technique requires label data to train the model for which the experience or ground truth data is required. In unsupervised learning, there is no label data and no training is provided to the model. The model constructs patterns from the available information. For example, the model is provided with a huge number of emails without spam and not spam labels. The machine learning models figures out a pattern from huge number of emails to detect unusual emails and classify them as spam or not spam. For example, if a person normally gets emails from sources such as contacts, professional societies, retail stores, and news channels, and suddenly there is a barrage of emails from unfamiliar contacts, car dealers, loan providers, insurance providers, and hair growth treatments, then the machine learning model will recognize a pattern of unusual emails and direct it to the spam folder. The technique used in unsupervised learning to group the data into different buckets is called clustering. This slide shows some of the differences between supervised and unsupervised learning. Supervised learning requires label data and training from which the resulting predictive models figure out a rule to classify new data and produces an output. While unsupervised learning does not require label data and training, it finds the underlying patterns from the data provided and groups new data according to the identified pattern. The supervised model uses regression analysis to make predictions. The unsupervised model groups similar objects using clustering based on multivariate statistical method. Let me try to explain this with the analogy of playing a video game. In most video games, the primary objective is to continually improve the score by playing the game repeatedly. Each time the game is played, the player learns from mistakes and tries not to repeat them, and that helps in improving the score. Similarly,
In the reinforcement learning, the model learns through an iteration process. Many audio, video, content service providers are using this technique to understand customer preferences. Such systems are called recommendation systems. The system is designed to get feedback from users on likes and dislikes. A thumbs up by the user is a signal that this is a good feedback, and a thumbs down means bad feedback and not to repeat it again. Based on feedback, the model constantly improves its performance in providing users with the media of their likings. Reinforcement learning can be very useful to improve a process by repeating the process repeatedly to improve a particular performance measure, like the score in the video game. Machine learning is a process where machines take data, analyze it to generate predictions, and use those predictions to make decisions. A machine learning system may consist of algorithms, data processing tools, machine learning libraries, data processing platforms. To produce a machine learning model, whether supervised or unsupervised, an algorithm is required. The classification of machine learning algorithm is based on the ability of the model to acquire knowledge. The supervised machine learning common algorithms include decision tree, linear regression, neural networks, support vector machines or SVM, and naive Bayes, and k-nearest neighbors or KNN. It's the best practice to evaluate machine learning model performance in predicting outcomes by running it against a few different algorithms to get the best fit and the best results for the model. Unsupervised learning works on clustering, and algorithms are k-means and principal component analysis. Machine learning libraries are used for analyzing, cleaning, exploring, and manipulating data. Each machine learning library consists of a bundle of algorithms, such as pandas, that is used for managing tabular data, NumPy, used for scientific computation, matplotlib, used for data visualization and plotting, scikit-learn, data processing, pre-processing and modeling, TensorFlow, used for deep learning. Hadoop and Spark are two most used frameworks for processing big data, which is generally the case when using machine learning to solve business problems. Hadoop is a framework for parallel computing needs. A parallel or a distributed computing system consists of a cluster of computers that communicate through a computer network for faster processing of data. Hadoop has two main functions, that is, to manage processing of data across multiple computers and provide storage for big data application. Spark. In Hadoop, processing big data slows down due to disk read and write for each of the three steps involved, that is, read the data, process it, and write results. Spark provides fast processing by eliminating disk read and write and processing data in memory or RAM. There are several data processing platforms available for faster processing of large amounts of data. Some of the popular ones are Google AI Platform, Amazon Web Services Platform, SageMaker, Microsoft Azure Machine Learning Studios, and IBM Watson. In summary, the steps involved in building a machine learning model include collect and clean data, select learning model, select algorithm, provide training, test and optimize the model prediction, feed new data for real-time prediction, and retrain if drift in data is noted. Deploying a model is not a one-time exercise. Since data characteristics can drift over time, a retraining may be required after the initial deployment. Machine learning application sounds attractive to extract value-added information from massive data sets to make informed business decisions. However, it has some challenges. Selecting an appropriate machine learning model, algorithms, and data processing framework requires expertise. Labeling, training, and validating data can be time-consuming. Here are some takeaways from today's presentation. Machine learning algorithms enable computers to make predictions and identify underlying patterns in real time with changes in data, unlike a traditional computer program. The field of machine learning is often classified into the following broad categories: supervised learning, unsupervised learning, and reinforcement learning. A machine learning system may consist of algorithms, data processing tools, machine learning libraries, data processing platforms. It was an honor to present this webinar from the American Society for Quality Statistics Division and Data Analytics Interest Group platform. I hope you enjoyed it as much as I did. Thanks for watching.
All right, so we are able to answer some questions now, and that was a lot of information, great information there. One of the questions that was asked is a very interesting question. Says, some experts say AI poses a threat, with some going as far as saying it poses a risk of extinction. What do you think?
Well, as you know, this is a continuation of several presentations, and AI is one of the topics that I'm going to cover in my future presentation. But let me share with you what I have learned so far, because I'm not an expert in information technology or artificial intelligence. My background is in mechanical engineering. And I've been learning and reading about machine learning and artificial intelligence because of it, to understand the quality 4.0, because I think as a quality professional, we'll be providing a bridge between, serving as a subject matter expert on a quality problem that we are trying to solve and working with a data scientist. So we are going to be like a bridge between the two different fields, that is quality and data science. But you see, the thing is that artificial intelligence, as I said during my presentation, can only be provide answers in yes or no. So, for example, if there's an inspector on a production line and doing an in-process inspection, and if he finds something unusual, that a kind of defect that he has not seen before, then he can say, okay, wait a minute, what's going on? This is something new. Let's look at it. On the other hand, artificial intelligence or machine learning does not have that capability. It's just going to simply reject the newly found defect
or it may not going to do anything because the model is not trained. So the role of having a subject matter expert in developing artificial and machine learning model is very critical. And I believe that it will always be there. So I don't think that quality profession is going to be extinct in the long run. I think we're going to provide a bridge between the two fields, that is quality and technology.
Another question, how can AI affect product design as well as in quality control, mainly in automation manufacturing?
Okay, I see there are a lot of questions on artificial intelligence. I'm going to cover it in more detail in the next presentation, but just to answer the questions, artificial intelligence is being used in mass production where 100% inspection is required. So the machine learning model is trained to classify the data into a defect or not a defect. So there is a huge application of machine learning and artificial intelligence and deep learning in quality. And in my last presentation, I also addressed the so many use cases of artificial intelligence in quality.
If you have an application, is there a good way how do you decide between using supervised learning, unsupervised learning, or the recommended learning, the three types you mentioned?
Oh yeah, the reinforcement learning. So,
Yes.
so for the, as I said during the presentation, for the supervised learning, you require the label data. So that is the deciding factor. If the label data is available, then yes, you can go ahead and use the supervised learning. But if there's no label data available and there's just huge amount of data available, then you can use the unsupervised learning. And to be honest, I have not seen so many use cases of reinforcement learning in quality. So I'm not sure how reinforcement learning can be applied to quality, but the most use cases that I've seen in quality comes from the supervised learning, and usually it's the classification of defects.
Do you have any other examples of machine learning in a company?
Yeah, I mean, as I said during the presentation, machine learning can also be used for predictive maintenance because normally, I think in most cases, majority of the companies are using the old model of maintenance, which is a preventive maintenance, which is based on a schedule. So whether a machine requires a maintenance or not, it's usually stopped and the maintenance is done. But using the predictive maintenance model, you can predict if certain part of the machine is going to fail in the future, and then you can target your machine maintenance requirements. So yeah, there are many use cases. In my last presentation, I've addressed many cases of use of machine learning in manufacturing.
One of the experiences that I've had is that creating the learning set, the training set of data can be quite difficult. Do you have any suggestions for how to get that learning set?
Yeah, this is true. This is one of the biggest challenge in using a supervised learning model is to have the label data set. So yeah, there are service providers that are now providing services where they have the data and they also have a label data, or you can provide the data and they can do the labeling for you. So that could be one of the option available. The other option is that you can use the unsupervised learning to classify the data. For example, this is a defect or this is not a defect. and use that for your supervised learning model for training.
Okay, thanks. Another question, if your quality department has a lot of data on parts, such as hundreds of capability studies in Excel, how would you suggest organizing the data to be able to use it?
Okay, let me understand if let me see if I understand this question correctly. So a company has a large amount of SPC data, which is coming from the X bar in our charts, or they have a large amount of data on process capability studies. I'm not clear, but in any way, using the process capability data, you can use the supervised learning because it can predict the future process capability if there are some variation in the material, if there's some variation in the temperature, pressures, or other factors that can affect the process. The machine learning model would use that information to predict what the process capability study is going to be. And same thing if the data is used for SPC charts, for example, control charting, it can also predict whether the next sample of the measurement is going to be out of the control limits or not.
Great, thank you. We have a few minutes left. Does anybody have any more questions? The YouTube channel where the past and this one recordings will be put in is at ASQ Stats Division. So you can look for this one shortly and some of the past presentations. And it looks like we will be having another one where we'll be talking about AI a little bit more. So that'll be coming. Doesn't look like I'm getting, oh, here's one more question. What challenges and considerations should be addressed when implementing machine learning solutions for quality assurance in small scale versus large scale manufacturing operations?
That is a really, really good question. This is always the challenge, how do we apply these technologies to small businesses? One of the biggest challenges is having the data availability. So for developing these models, because they work on a statistical prediction models, you need to have a large amount of data. So for I guess for the small businesses, it's still going to be a challenge whether they can apply these state-of-the-art technologies for their operation until and unless there are more developments in the future that can help to minimize the cost and also help to minimize the complexity of developing such a state-of-the-art technologies. So yeah, this is really a good question, but I guess for now it's really a challenge for small enterprises to see the benefit in using these some of the new technologies.
Great, thanks so much. Well, I want to thank our speaker very much for all the information. There was a lot of very detailed information in that presentation. Apologize for the difficulty getting that going. Thanks for your patience there. And I hope to see you again in our presentation on AI that'll be coming in the future. Hope everyone enjoyed the presentation today. Thank you so much.
Thank you, everybody. And Jennifer, thank you so much for making this possible today.
Okay, thanks everyone. Goodbye.
Bye.